So 2.4 is oftentimes a bit of a challenge in this course because what we're going to be doing is math without really any numbers, which gets to be somewhat abstract and really challenges us as we practice using that addition property and the multiplication property. Really, what I have to stress in this is that it's really the same as what we've already been doing. So in these ones, we're going to be dealing with literal equations. So it's basically a formula. It's that the perimeter equals twice the length plus twice the width. Now, we saw those algebra things as algebra expressions before. And so now that once we say it equals something, that expression has been turned into an equation or a literal equation or a formula sometimes. And so oftentimes in dealing with geometry, you want to manipulate an equation. You want to rearrange a formula to solve for a specific variable. So maybe you have everything but the width here. Well, this is set up to solve for perimeter. So rearranging using the property of addition and multiplication, you can reorder an equation so that it's solved for what you're looking for. So it's really the same thing, but with only variables now, or well, mostly variables now. So let's go through a couple examples of these ones. And so oftentimes you're given the initial equation and then you're asked to rearrange it. So this area equaling half the base times the height is the equation. And I can call it an equation now, not just the expression because it's got the area equals the equation for the area of a triangle, but it's solved for area. So this one's saying rearrange it, make it so that it says H equals blah, 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 or B equals blah, 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 right? And so that's what we're trying to do with these ones when we rearrange a formula. So I'm going to rewrite it out and we're going to start with these ones slowly here. So this is my original equation. Area equals half times the base and the height. And I'm trying to solve it for height. And wouldn't you know it, we have fractions here. So if we go about my strategies for dealing with fractions, I see the 2 down below. That would mean I need to multiply everything through by 2. I'm going to cross the denominators out and write everything above board. So I now have a 2 times my a, whatever that is, equaling my base times my height. So again, I'm trying to get height all by itself. I'm trying to get this h all by itself. What's going on between the b and the h here is multiplication. If that b was a 2, you would know to divide by 2. Well, it's not a 2, it's a b. So we're going to divide by b. And that means we need to divide this side by b. So I now have it organized so that I have just the h on one side and ended up more conveniently on that side. But I could rewrite this so that h equals 2 times a over b. And that's my formula rearranged or solved for height or for h. Let's try that one again. So this time we're starting with the same formula and it's going to be really similar, but this time we want to solve for b. So I start out that same way. I've got fractions and I don't like dealing with fractions, so I'm going to get rid of them, rewriting it all above board so that I can see what's going on. And again, this time I'm trying to solve for b. Well, what's going on between the b and the h is multiplication. If I divide this side by h, that's going to get rid of the h. So that means I need to divide this side by h. And again, I've solved this so that the b is on the right-hand side, but I could rewrite it so that b equals 2a over h. And I've rewritten this formula solving for the variable that I was being asked for. I'm going to scroll here a little bit. We've got 4 at the bottom of the page here to give a try to. Some are similar. I'm going to talk through all of them just to give us that practice, sort of hearing the thought process behind. So I'm going to rewrite this one so that I can see it a bit better. So this one I'm supposed to solve for h, and I've got fractions. So I'm going to get rid of my fractions by multiplying everything through by that number. Cross it out, write it all above board. And even though this is the volume for, I forget what that one is. I don't know, a cylinder or something like that. I can't even remember. I'm going to solve for my h by dividing both sides by b, and I get h equals 3v over b. Not very satisfying, not really like h equals 2 or something like the solutions that we've been dealing with, but the mechanics here are exactly the same as far as what you're allowed to do when you are rearranging them. So for the next example, b, we're supposed to rearrange this to solve for b. So I'm going to rewrite it. Somehow that just allows me a little bit more processing time or something. And I want b all by itself. So what's going on between b and this mx is addition. If I wanted to move the mx away from the b, I could subtract it, which means I need to subtract it from the other side. We're used to being able to actually subtract or do things. In this case, we're stuck with just the letters. So y minus mx is the best we can do on this left-hand side, and that actually equals the b. In one step, we've got the b all by itself. If you wanted to reorganize it so that it was a little bit neater, you sure could. But we're not really doing any work between those last two steps. We're just flipping them one side for the other. It's still b all by itself, which is what you're trying to do when you're solving these equations for the variable that they're asking for. C, we're supposed to get y all by itself. So again, you don't have to rewrite them, but sometimes I like it just because it gives me a minute longer to think about things. I'm going to subtract 3x from both sides because that would get my 3x away from my 2y. I don't start with the multiplication property. You always start adding and subtracting terms to move them around. And now that I've got this, I'm close to having y by itself, but I still have the coefficient. So if I had a coefficient in front of anything that I was solving for, I'm dividing both sides by that coefficient. So I get a final answer of y equaling 12 minus 3x all over 2. This is your final answer. And in knowing that it's your final answer, I would remind you that this is a grouping sign. We can't go in and divide the 12 by 2, even though I know I can divide 12 by 2, because this groups those together. It's as if they have brackets around them. And so that I put a box around before I muddled it all up, is your final answer. Maybe I can clean it up again. All right, so the last one. So this is something that we have, or I've talked about before, in that this V1 and the V2, even though they're the same variable, they're actually different values. So this is an initial velocity and a secondary velocity. So we need to treat them as if they were different letters entirely. So in this question, I'm supposed to solve for t. So I'm going to rewrite it. Again, I don't know, this is just part of my processing. So t is what I'm trying to get by itself. I'm going to start by getting this term away from the gt term over here, and I'm going to do that by subtracting v2. So even though these v's are the same letter, they're not like terms because of that little subscript, that 1 and 2. So v1 minus v2 equals a g t. And t is what I'm trying to get by itself, and I have a g being multiplied by it. So if I divide by g, that's going to get rid of it on that side, but I need to divide this side by g. So I get my final answer that t equals v1 minus v2 all over g. And this specific example is a motion equation that you use in physics because you have acceleration. This would be acceleration due to gravity. So things are going faster the longer they fall. And so this is the applied example of that. Do a couple more here that are tricky. E is pretty straightforward. F is assigned in your homework, and it actually looks a little different. So it gets a star. We'll give it some talk, and then we're going to do one application of this in this 2.4. There's lots of examples for you to try in your notes, and make sure that you ask for support in these ones. So maybe we'll try E. You can do it while I do. I'll try and not talk so much. Your answers are certainly messy in these ones. They're certainly far from a nice, neat, tidy number. But yeah, give that one a shot. F, I'm going to talk through so that you have a little bit of an approach. So I'm going to rewrite it. And what we're trying to do is solve for C. Well, in this one, I see fractions. And every time that I've seen fractions, I've given us this strategy of multiplying everything through so that you could clear that denominator. I'll switch colors again because I scribbled it all in there. Wiping out my denominator and then writing everything above board. So I have to cheat on that one. 228 or 288, sorry. And C is what I'm trying to get by itself. So I'd subtract 288 from both sides. So 9F minus 288, whatever the heck that is, equaling 5C because that all wiped out, and then divide by 5. And this has functionally solved this equation for C. So your textbook is going to have a different answer for this one. So when you do go about this one, you can double check with me if you're like, yeah, I think I did everything right, but can you tell me if I'm right? Because our approach of clearing the denominators puts you in a different place than the textbook. So this initial step kind of changes how the question or the answer looks, but it doesn't change the meaning. So this one is that case of you going to Seattle maybe for a trip and looking at the weather forecast and trying to figure out what 63 degrees out is for a high. So that this would be turning it back from Fahrenheit into degrees Celsius. A practical thing, but usually we have other ways of doing it rather than all of this algebra. But it certainly does make us use our addition property and our multiplication property to reorganize these formulas so that they actually produce the numbers that we're looking for here. So an application of this one, just trying to, again, make you kind of buy into why the heck are we doing this? In that it says there is an equation that explains how much money you'd have after some time if you invested some money that had an interest rate attached to it. So this is where you get to play pretend. So pretend you have $5,000 to invest. That is your principal. And we know we have $5,000. And it's invested, and eventually the amount is $66,050. So this is the amount at the end, and that is 6050. Now it says that it's in there for 3 years, so that would be the time. And oftentimes we pick variables that make sense with the thing that they're representing. So V is for velocity, right? So the time is in years, it's 3 years. So this one says, what is the interest rate? So this is the rate, and this is what we don't know. This is what we're trying to figure out. So we do have an equation that amount equals the principal plus the principal times the rate times the time. And so what we would like to do is solve the original equation for R and then sub in the value. So I'm going to, just because I've got the space, solve for R up here. So if this is my original equation, R is what I'm trying to get by itself. So I'm going to start out by getting this P away. So I'd subtract P from both sides. A minus P, those would be gone, would equal P R T. And every time I see this, I think of the nursery PRT. Anyway, that's more of a tree planting thing than an interest rate thing. So again, I'm trying to get R by itself. Now, I have both P and T being multiplied by R. So if I want to get rid of them, I could just divide by both of them at the same time. So this would, for all intents and purposes, rearrange the equation so that R equals A minus P all over P T. So now that I have an equation that's all organized for what I'm looking for, I could sub my values in to solve for the value of r here. So r would equal a, subbing in with brackets, 6050, minus p, which is $5,000, all over $5,000 times 3. So on my calculator, I would get 1,050 divided by 15,000, and my R comes out as 0.07, or this is the rate as a decimal. If I wanted to give it as a percent, I would multiply it by 100. So 7% is your rate. So one little application of this stuff, it certainly is a bit of a stretch to go into this abstract world of doing math without any numbers and all letters. Like I said, give it some time with your homework questions, but do prioritize that 0.1, 2, and 3 because I really think that they are the key to this.